This is the build tutorial for the PVS-69. Alright, so getting started, things you'll need. You'll need this cable right here. It's a DC 5.5 millimeter by 2.1 cable. The exact length, I can't remember off the top of my head, but it's long enough to reach across your helmet. You're going to need a pack of these. This is a 5.5 by 2.1 female jack. It's got a little weather seal as well as a little plug on it and a little O-ring thing and a nut back there. You're gonna need, this is a focal lens out of the Google VR cardboard headset. This is the 3000 milliamp hour 5C 7.4 volt battery. This here is an optional piece. This is a Runcam FPV DVR. It takes a micro SD, so you'll also need one of those. It is not included. Adafruit 2-inch TFT with this is the NTSC/PAL, same one I use in all my designs so far, but future things are coming. This here is the Runcam Night Eagle 3. However, this design will work with the Runcam Phoenix and the Foxier Nightcat 3. This is just the harness for the Adafruit, pre-soldered up to the Night Eagle, but we will be cutting this joint to install the DVR. Clone G24 mount from Sotac. It's actually a really solid mount. Definitely recommend it. It's about $80. This camera here is about $70. These screens are about $40. I believe this is under $20 for the DVR, and this battery is about $12. These connectors are only $7, and this is about $7 as well. So a little bit of investment into this. Oh, and the VR headset is $10. You get 2 lenses out of it though, so $5 for the lens. Kind of a small investment, but you know, it's worth it for the system being what it is. As far as printed parts go, you'll need your sensor cap. This is the sensor screw. It's already installed, and there's also the key already installed, but I will talk about that in a second. This is the bridge. I've only roughly cleaned these parts up, so we will be cleaning these up for this video. This is a different bridge design, only because my previous ones would not actually lock into this. These tabs were at an up angle, and they actually hit this mount and would not lock in. This mount is pretty freaking solid, and it locks it in pretty solid. This is the side panel. This is a unreleased version, which I'll be releasing shortly. This one is specially designed. It's got some more real estate in there, so you can install your DVR, and then it's also got a cutout for your DC 5.5 plug. You'll need, this is called knurled piece. Didn't know what else to call it. Initially, the design was supposed to have an integrated battery. Still working on that. Thinking about what kind of battery I want it to run. I don't know if I want to go with AA's or if I want to step it up and use the CR123s, which is what most items take. This is the J-arm. I believe this is for the right eye. This is the long lens thread. It's got this little, this is actually a fixed piece on there. It lets you turn it and adjust it. I have pretty bad eyesight, and I wear glasses, so without glasses this makes it easier, so I can focus on the screen itself, and I can adjust this to do that. There's a small jam nut and a thick jam nut, and then this is the lens cap here. Alright, so let's get right into assembling this. We're going to take our lens, and it does not matter which way, but I like to do, there's a little, it's super hard to tell, but there's a little flat, one side has a little flat rim, and I like to put that flat rim towards the outside. And we'll set that down for now. We'll take our small jam nut, screw that on here a little bit, and we'll screw on our sensor thread. The sensor thread, the threads are not cut as deep as I would like them to be, and that's only because it's hard to get that lens on there with also having those thick threads. So I rely on the jam nut to kind of hold it in place. And if you're satisfied with your model, what you're probably going to want to do is just a little bit drop super glue on them threads to lock it down tight. Just hit that with a couple drops of super glue and you're good to go there. You're going to take your thick jam nut, screw it on the other side. And let's talk about the body real quick. So this is the horizontally printed body, so it's meant to be printed flat. I also have a body for printers that struggle to print threads. There's a body that prints vertically, and the threads will print a lot better that way, because these horizontal threads don't always turn out nice. If you have detect thin walls on, you'll get these little messed up pieces in there, and that's just something that the printer generates in there. I'm not sure why, because the model does not have those in there, but detect thin walls off, those will go away. This body seems to work fine, so I'm just going to run with it. With your sensor screw, there's a little square tool that you also print, and you print that tool sideways so the hex head sticks off to the side. That way you don't just stick it in there and snap it, but you stick that tool in there and you tighten that in with the tool. So you put your square tool in there, you'll tighten your sensor cap on, and then you'll use I think it's like an 8mm, and you'll just tighten like an 8mm socket and like wrench or whatever the heck you want, and just tighten that in there. And then you want to get it to where these channels will line up, and there's the keys. You stick the key in there, you press it in. There's a T marked on the key. There's a T on this key. Due to the resolution of my printer, the T didn't turn out so well, but that T is going to face forwards. So you will drop your key in like that and press it in. It's PLA, so it'll fucking conform nicely in there. If you just smash it in, you smash it in there. I use a chisel. I just pressed it downwards as far as it could possibly go, and then I just cut it off. I just pressed the chisel into it and I took the chunks out, and that allows for the sensor cap to mate nicely with the body, just like that. Alright, so once we're this far, the next thing we're going to do is we're going to take, optionally, some Teflon tape, and we're going to wrap Teflon tape onto the these threads here. And what that's going to do is it's going to help weather seal this, but also make it so you're able to turn it easy, because this Teflon works as a lubricant in there. It can also help if your threads are tight too, because this Teflon will lubricate those threads. I'm just rolling it back because I don't want it to show on my screen, and you just tighten that in there now. You should never be able to hit your screen with this because there are stoppers in there, but just be careful when you're tightening it in to make sure you don't accidentally blow through those stoppers, but there is stoppers in there. You might be wondering what this is. This is just a sacrificial layer that is in there to prevent the printer from putting supports inside the body, because it's just unnecessary plastic used up there. Mine does a pretty nice bridge right across there. It's a small area that gets bridged because the inside of the body is cut in a certain way. But you can remove these if you want, you don't have to. So you can just take a razor knife in there and you can just kind of cut that material out. It's just little strands in there, it doesn't really matter. I'll do it just so I can show you what the inner geometry kind of looks like in there. It's not really attached that well anyways, because it just printed over thin air. It's fairly large to be a bridge. There are these pegs here. You don't want to break them off like that though, because PCB does sit on those. It's not super necessary, but it helps. Well, I got most of those out, so once you're behind here, you see it's pretty chamfered, and you know, that's a little bit of bridging, a little bit of messed upness in there, but nothing that you should worry about because this thing is plenty strong. All right, so we'll move on to wiring this. All right, yeah, we'll talk about this side panel for a sec. This side panel will fit in there. It should be pretty snug fit, not anything that you gotta break it, but should be pretty snug. I just noticed a flaw in my model as well, as I don't have a bolt hole coming all the way through the front here. That'll be fixed before this is released, because looks like the hole goes partly through, but not all the way through out the front. Hey, look at that though, we're fixed. We got a hole in there now. All right. This piece, the knurled piece, should fit in there nicely. Like I said before, this is meant to have like an integral battery design. Could not find a battery that fit properly. One of the RC batteries anyways, which I was trying to get a hold of. Couldn't find one that really fit. All right, as for wiring this thing. So first, let's talk about this. You're gonna go from this is your camera plug-in, or your screen plug-in here, the big connector. And you're gonna go white to yellow. And then you're going to go yellow from the screen to ground. And you just connect all the grounds together, and then I run these all to one connector. And from your camera, you're going to go red and blue to red. And I just have these connecting halfway up, and then, you know, the full connection comes out the end there. So I got two connectors, hot and ground, camera, screen. This is for the OSD keypad, which mine actually burnt out because I actually shorted it somehow. I don't know. It just fucking stopped working. But I think it burnt out. But there's your sensor right there. These bodies, the screen will just drop in here. It should be a pretty snug fit, but not too tight, obviously. And then the PCB will press onto those pins right there. I snapped that third pin off, but if I hadn't, it would have pressed onto the third pin. And you can take like a soldering iron, and you can just press these pins down with a soldering iron, and it'll lock your PCB on. I'm gonna pop that out for just now. Alright. Your camera, there's a slot for the camera that goes in there, and it just slides straight in. You see the slot in there, and that just fits right there. You hold off on installing the camera because you want to run the wire out, plug it in first, otherwise you're really going to be struggling. Alright, so for this connector, I probably got way too much wire on here, but I really don't care. I actually don't know if I'll be able to run this DVR because it says 5 volts and I have a 7-volt battery. Let me just pull up the specs real quick on it and see if I can actually run that off of 7 volts. Alright, so this actually runs off 3.3 to 5.5 volts. So you can't actually run this with your 7.5 or you'll burn it out. So we're gonna hold that off for later and we'll talk about that, what we can do to work around that. So we have our wires all connected up here for a camera, screen. We have our hot and ground, and we have our hot and ground. So we're gonna need some shrink tube. I have a link for a little soldering kit that you can get, and it comes with a bunch of this shrink tube, so you won't need to buy that. I'm just finding some shrink tube that'll fit these wires nicely. This will fit on here. Will it fit this? Alright, next size up. The annoying part is they pack it all into this little baggie, like the super big ones and the micro ones, and so it's like kind of a pain to dig through there and find the size you need. I'm just gonna have to go with this size right here. It's the closest one to it. Soldering iron's already heated up, ready to go. So we'll just lock these in the little handy helper. And get this rolling. I'm gonna get a little more strip on this wire. This is a pair of wire strippers that I got from Harbor Freight, I think, but I'll put a link for those as well. I was holding off on making this build tutorial because I wanted to do a full binoc setup, but my printer was being weird, and with the same exact G code, it printed two bodies that were different. I don't know why, but one could not be threaded and one could. So the way I solder wires is lazy, and I normally just twist them together. I do sometimes fan them out a little bit, so the fans can the wires can get a little more intertwined, but I just put them together and just twist the whole thing, and then I just lock it together with solder. Like I said, the soldering kit has everything you need. This is soldering paste, quote unquote, but it's not like soldering paste like you would actually have for PCBs. It claims to be like a resin or something, like a yeah, I don't know, it's weird. But anyways, I just put a little bit of that on the wires. I always put a little bit of solder on the gun just because I feel like that helps it, and I feel like the soldering irons melt the solder a lot better when there's a little bit that was directly on the iron to start with. And then there we go. That's a nice and pretty solder joint, but forgot the shrink tube. Great. Yeah, just snip this off actually. Try again. Never fails. I get a good soldering joint, a perfect soldering joint, and then I see the shrink tube sitting next to it. Literally does not fail every single time. Just stripping these wires. Okay. I've been reusing these Adafruit screens for all my builds. I have to keep resoldering, and every time I take off a little bit of wire, it's starting to run a little short. Alright. Oop. Almost fucking did it again. pack those on tight. Maybe this is real solder paste, I don't know. We'll see. It did seem to melt right into the wires and kind of disappear, but who knows what the fuck it is. It's all from China. A lot of people like put a sponge on their soldering iron or whatever, and I don't really know what the whole point of that is. I'm not good at this stuff, I just do it. So I normally keep the tip of the soldering iron on the end of the wire, and I push the soldering iron into the base, or I push the solder into the base, and that makes the solder flow through the whole joint to make it all pretty solid. And that's pretty good right there. Fold the solder joint that direction, run our tube over it, and if you don't have any other type of heat source to shrink this, you can just take the barrel of your soldering gun and just rub it on there, and it'll shrink that tube up. I think people normally recommend using a heat gun. I have one, but it's all the way in the garage, and I'm not going to bust it out just for this. For 10 seconds of use. Ooh. Don't burn yourself. It hurts. That's one of the reasons that I kind of don't want to sell these as a finished product, is only because of the soldering. I don't want to burn myself. I always burn myself a ton. I do have some like crimp connectors, and I bought them, and they were supposed to be the ones that like you stick the wire in there and you just solder it, and it like heat shrinks and solders all in one, but it actually doesn't work for some reason. The ones that I have, I don't know why, but alright, so we got a solid soldering joint there. Take our positive end, strip it off, untwist it a little bit. Looks like I did accidentally run the wrong heat shrink tube on each side too. So since I put the red one on that side, I suppose I'll just have to put the black one on this side. Should go over this side pretty easily. I think they actually recommend that to have your heat shrink tube colors switched. That way you know which one is which, so you don't accidentally confuse them. So you don't think that your positive is actually a ground positive when it's actually a positive ground. Some solder paste on there. It did come with like a little injector for that solder paste, but like I said, I don't think that's actually real solder paste that you would inject onto a PCB, so it just seems to turn into like a liquid and flow away when I start doing this. And the website says it's like a flux, but it's also not flux. Alright, there we go. Nice solid solder joint there. Fold that over. Push our heat shrink tube over it. A little far forward on that heat shrink tube, but that's fine. Alright, that's not going anywhere. So now we have our fully assembled harness. You can obviously clip these wires down more if you want. I'm not going to, just because if I do clip these in the future, I'm going to clip on the red and black and keep these soldering joints where they are. Installing into the body. You're going to flip your PCB forward, or you can just gently pull on the sides of the screen, not on the ribbon cable. You got to get in here on the sides of the screen, use your fingernails, kind of wobble it back and forth and lift upwards. You can actually get your finger in behind it as well and slide it out. That's just for ease right now while we do this. So we're going to run our wire harness here. If you get the Nightcat, the Fox Ear Nightcat, it has a super long harness. This Runcam does not, but the Fox Ear one is so nice for this. It has a really long, like, braided wiring harness that comes all the way out through here. So you want to pull it up far enough. If you're not going to do any OSD stuff right now, you want to pull it far enough that you can plug it in, but you don't pull your OSD through, because it won't fit back in there nicely. It'll be hard to put in. So then you just push your camera into place. If the camera does not fit in there and it's too tight, you'll take a chisel and just kind of scrape in there. Usually I get a little bit of like over extrusion material in there, and it should push in pretty far down. You can see that it should push in pretty far. I think my camera slipped at some point. Fuck. Alright, so once you have that plugged in there, you're gonna push that camera in to where the it sits pretty far in there. It should stop, and this should come out kind of perpendicular. If it doesn't come out perfectly straight, that's fine. One thing to note, this is meant to be an extremely snug fit on your lens, and so snug that it's meant to be able to turn your lens when you turn this, so you can adjust focus on it. So what you want to do is hold off installing this for now, and you want to assemble the whole thing and get your camera roughly to where it needs to be. While we have it apart, we're going to go ahead and install our J-arm. The J-arm is a pretty simple design. Make sure that this is a decent fit before you go ahead and push it on there, because you don't want to bust this J-arm. It's gonna just push in here, and you're gonna pry on it, and you're just gonna pry it over the edge right here, and it's gonna snap on. It's pretty snug the way it is, but we lock it in using a, what is it, a 3 millimeter hex. Take your Allen wrenches. Too big. And screw it on with your Allens. And then there's a slot for a nut on the bottom side, so use one that's long enough to reach through the nut. It will kind of thread into the body, but you know, use a nut. Alright, not long enough. Let me see. This was a 12 millimeter, so you'll probably need a 16 or a 20 millimeter to fit all the way through. I'll just roll with the 16 since that should... Alright, no, it's an M4. I'm sorry. That screw is in the wrong location. So it's an M4. And it'll come poking through the bottom, and you'll put your nut, your M4 nut on the bottom side, and it's sized pretty well to hold the nut so it don't spin. You don't have to crank this down tight. That J-arm's pretty solid on there, but this is just for security to make sure it doesn't come off. Alright, so that's on there. Just tighten it a little bit, and your J-arm's locked in. Your harness, you're going to want it on the top side. So just keep everything pushed upwards to the top. Your OSD cable can also come up the top. We're going to reinstall the screen. And Alright, keep your wires on the top side of this nub too, so you can stick your PCB on with no issues. Install your JST connector for your board. And then wrap your wires around. And if you're going to do any OSD stuff, now is the time to do it. You can, obviously now everything should work. You can plug it all in, confirm that it turns on, that it does work. The camera is wildly out of focus right now, but that's what we'll work on next. Alright, so what you want with your camera is you want to, as far as focus, you want to screw it outwards from your focus just a little bit, because tightening that cap on will affect the focus. And then this nut, it actually seems like my lock nut is broken. Alright, there we go. Lock nut's free. Must have just had something in there. So you'll screw that on and you'll get it in focus, and then you'll turn the lens counterclockwise a couple rotations, and you bring your J or your lock nut pretty close. And we've set the focus on your camera. And then for this, you're gonna wanna take, I use a chisel, and I take this edge of this chisel and I just kinda run it in there until it's a super snug fit on this camera. Oh, this is actually the wrong sensor cap for that camera. Sorry, that was the box ear sensor cap. This is the right sensor cap, and yeah, just scrape it out with the edge of a chisel and make a super snug fit to where it kind of presses on, but then it's going to start threading. But what you don't want is you don't want to mess up your focus too bad. So let me see. And this does stay in there, and it's pretty freaking watertight. I mean, that's about as watertight as I'm able to get that set up right there. And so this can be a pain once it gets started in there to get back out. Oh, fuck. Alright, so what I'm doing is I'm bringing that jam nut more forward, just because I'm having a bitch of a time with it. Tighten the camera as much as I can, or no, don't tighten the camera in, I'm sorry. Wow, I'm fucking up right now, huh? So I actually accidentally pulled my camera all the way out, so I gotta get back behind there. And this body printed these nubs so fucking weird, and they're terrible. They're not even like round. I don't know why, but like I said, my printer was fucking up. Printed the same G-code 2 different ways. One of them worked and one didn't. I'm just gonna unplug this for now. Take my screen out so I don't damage it. back through there. I'll probably edit this whole part out. Alright, so we're in here. Got our camera body right there. Plug the camera body in. Alright, so I got it all back together. A little bit of a hiccup there. So what you're going to do is you're just going to like gently hold this PCB in there, and you're going to work on that camera focus. And you'll notice that it'll make some creaking noises and stuff, and that's just that lens being pushed on there. And you want to over focus it a bit. So tighten it a little bit more than it needs to be, and then you can back it off and get your focus dialed in that way. And I usually focus these at about 15 feet or so, and that's just because it seems like a pretty good distance for, you know, short range and long range, inside a house and outside. You can actually tighten this a lot more. I just tighten it all the way in and back it out a little bit. Alright, and that should be, you know, fairly waterproof in the front. Obviously it's not perfect up there, but if you want to wrap Teflon around that before you tighten this in, or you can even do it now afterwards, you can still wrap Teflon on there. The camera pokes out a little bit on this one. That's strange because it hasn't on any of the others, but you know, each build is going to be slightly different. So we got that whole part assembled. Now we're just gonna unplug it. Oh, it's a tight plug. These are supposed to be water rated. These plugs here. Oh man, I really fucked up, didn't I? Damn. All right, so this has to be installed through the body first. Forgot about that. So we're gonna cut straight to this piece being installed. We're gonna have to take these wires off and resolder it while it's all threaded. Alright, so we're disassembled. I did want to note that you're gonna want to take this washer off of here and set that aside, because the washer does go on the back side. So you install this through the hole. This should press in. It's best to have those flat spots vertical, since there is flat spots on the top of this, and it's on the vertical side. It's pretty snug without the nut, but the nut locks it in and lets you crank it down. So stick that nut in there. Yeah, you just want a nut in there real quick. And sorry, you just thread your nut on there. Alright, so we'll take, again, for probably the 15th time. Whoa. Heat shrink. Can't forget the heat shrink. Adjust this camera a little bit. Don't forget your heat shrink tube, because that's annoying. Don't forget to run it through the side panel, because that's also annoying. Alright. Got a heat shrink on there now. Fan them all a little bit. Press them together, twist them up. A little bit of ye olde solder paste again. Just scoop a little bit out on there. A little solder. It's actually significantly harder without this guy holding it for me. This is my little helper guy. That's what I call him because it looks like a little person. And start pressing some solder at the tip and then run it at the base. Let get a nice solid solder joint all the way through there. Kind of speed running it this time just because this is the third time I've done it for this video. As you can tell, these wires are getting pretty short now. Not ideal, but takes up less space in the body, so it's not terrible. A little bit of this paste on there. That's probably way too much. Right, a little bit of paste on there. Alright, solid joint there. If you do run out of this solder, you can go to Harbor Freight and they got it there for like $7. It's the same shit. It's resin cord solder. Heat shrink. So fold these over. Slide your heat shrink on there. That one this way. I normally fold it the way that it feels most natural to the wire. So whatever way the wire like wants to go, that's the way I push it. You might notice that this one's yellow. That's because I ran out of red. So yeah. You can cut these in half. I'm not doing so because I don't plan on doing a ton more of this soldering. Let's see this nut. Will a printer wrench fit it? Just too, no, it's not even that the wrench don't fit, it's that. So your printer wrench will fit it, but it is just a tight area. Actually, the printer wrench does not fit it. All right. So we'll grab our handy dandy multi-size wrench here. Alright, this is not easy, the nut's pretty thin. Just snug that up a bit. This piece does act as a seal behind there. That's why I chose this one, because water can't get through this port. You have a little dust cover plug right there, and it also seals to the body, which is nice. Alright, so what we'll do is we'll just coil our wire up in there. If you were to do any OSD stuff, do it now. Your plug's right here, ready to go. But I am fine with how my camera is set up. I normally set the cameras to black and white, just because any other mode does not seem to provide the quality picture for night vision. And I'm sure there's probably some of them snobs out there watching this video talking about, oh, tubes is life, tubes is life. Fuck you, don't care. Digital is the future. Alright, so coil of wire is not wanting to fit in there. too easily, but it will fit, I promise. And if it won't fit, we'll make it fit. Alright, so that should press together. It doesn't really hold together really well. And the thought here is that if you want to completely seal this unit, you can run a soldering iron along this edge and melt these two pieces together, and it should be, you know, like almost 100% waterproof. So it's this wire right here at the top that's pushing me out. Alright, we'll just send it like that. So we'll pop open our handy dandy screw box. I have a link for this as well. Run a 16mm through there. Should fit just snugly though. This is a 3mm hex head screw. These are these rounded ones. They're not quite as cool looking, and I don't think they're actually as strong as the, you know, like the head's more like, actually got one somewhere over here. They're not quite as strong as these heads. These are probably the better heads to have. So I'll have a link for that box of screws instead. I think it's actually a little bit more expensive, but probably worth it, since these ones tend to strip out. The head does. It's probably just because they're all made in China, but so this isn't actually meant to thread through the body, so if you want to drill this out, you can. It's meant to go in and have a nut on the back side. I need to get some hex bits for my drill. This is toxic having to do this all the time. Before we get this too far together though, we're gonna plug her back in and see, triple check that it all works. Alright, so we are working fine. As you can see, you can actually adjust the focus with that front piece. So that's nice. And then if you find that the focus on the screen is not what you're looking for, you can adjust that as well. And I think that's a pretty handy feature to have, since a fixed focal lens might be good for some people, but say your model doesn't print perfectly, it could mess up, and you'd have a kind of a permanent, slightly blurry view and have no clue why. Alright, so I'm just gonna fucking back this goddamn hex out. Alright, here's what we're gonna do. Just sub the drill bit through this other one. Spin it around in there. Make sure the next one we fit through actually goes. 12mm. Might be a little long for this. Probably do an 8. I'll just do an 8. Let's see, 8. 8's almost on the short side though, so your call there, I guess. This doesn't have captive nuts because I think CNC Kitchen did a video on it, but I think that having, you know, a nut on the back side of something is just a stronger design than having a nut melted into the plastic of something. But I have to refer back to that video to know for sure, but I think that this is probably the better way to go, just to put a nut on the back side. And of course you can run these screws either direction, but I'll probably just cut this part out and cut to where it's done. Alright, so I went ahead and drilled those holes out with a 7/64 drill bit. Just the side plate. I didn't drill out the body just because the body also, you know, it helps if it's threaded into the body a little bit. So we'll go ahead and tuck our wires again. And I might modify this a little bit to make those wires a little bit easier to tuck in there just because they're so tight right now. It's because this thick portion of the body right there is pressing against the wires, and it's just kind of a snug fit in there. And the wires want to go underneath the body and between it, and it's just not a good fit. You do want to make sure you're not crimping that ribbon cable in there. That ribbon cable should not be pinched in there. Yeah. These fucking wires, man. I tell ya. So like I said, don't pinch your ribbon cable. Thinking about putting in a little spacer piece that you can stick in here that fits into this area, holds the PCB down, holds your screen down, and probably lassos your wires up a little bit too. But have that be like an optional print piece for people that are struggling, like I'm struggling right now. Fuck, man. Probably would help if I cut these wires a lot shorter up here. I'm just gonna twirl it all up. Alright. So like I said, don't crimp that ribbon cable in there. It's called a bad day right there. I just stuffed those wires a little quickly. I just poked in there with an Allen to push those wires where they should be. Alright, so it's fucking still tight on there. Even a 7/64 drill bit didn't seem to do too much in the way of hogging this out, so. There we go. Now we're sliding in there a little bit better. Just kind of let it ream itself out a little bit. Run that screw in there. I don't think a washer will actually fit on the back side. Oh, fuck. Will a nut fit on the back side? Damn. So I made some modifications to the body from the one that's released. And this one, the nut will not fit. So looks like we'll have to flip this the other direction. All right, so it's gonna go this way. So your top screws will go into the side panel from the body. Then you'll slap your washer if you want to run one. You don't have to. And your nut. And I find that if you just hold the nut with your finger, tighten it, it's pretty good for these plastic ones. I mean, that's pretty solid on there. This one, it is meant to go through that direction. Obviously want to be careful drilling now that it's all the wires are in there and shit. This one will take a 20 millimeter though, because it is quite a far shoot through there. I do the bolt head on the outside for this one. It was supposed to be a little area, but that must have got deleted in the model without me noticing. So quite a few things I gotta fix here. Not too bad though. Let's see what's going on. So it's not coming through. This is how I fit this. So you can use one of the Allen wrenches that comes with your printer. It's a lot nicer than that little black one I have. That sucker's sharp and it hurts and wears on your fingers all the time. Oh, I also just realized that I do have what I said I needed to get. There we go. Fuck yeah. Careful with these though, because drills can be strong and break plastic pretty easily. I'm sure someone's experienced that before. Washer, nut. There we go, that's an assembled piece right there. I just need to back this off a little bit and stick our nut into the slot. It is slotted out to hold a nut in there. I've actually never put a nut in there since I've assembled one of these, so we'll see how well that groove holds. Motherfucker. Alright, so the nut did go in there. I over tightened the screw a little bit. We'll just make sure the screw's snug still though. Yeah, I over tightened the screw a little bit, sunk into the body, or sunk into that side. That's fine. Here's a completed unit right here. Got your dust cover for your power plug-in. It's all set to go. Now, take our bridge. Like I said, this is the right side, so you want to fit it. Thick end of the bridge, thick end of the dovetail is the front of the bridge. Take my trusty little scraper in there, chisel out those little hairs. Chisels are sharp, don't cut yourself. But they're also probably my favorite cleanup tool for 3D prints because of their versatility. So you just want to clean that up to where it fits nicely in there. You don't want it to be loose. You do not want it to be loose. But you don't want it to be too tight. Sorry if I keep pulling it out of view. My arm's resting on a place that's kind of uncomfortable for it. But alright, so what we're going to do here is we're going to run a drill bit through the J-arm. This is the 764. Hog it out a little bit to make that one sit loose on your M3 by 20. You want the M3 by 20 to be able to pass through it without, threading it too much anyways. A little bit's fine because that tension will be nice. But then you'll just, without hogging it out, run the drill bit in there. Your M3 should thread in, and that's kind of what you want here. Slide our J-arm into the bridge. Actually, before we do that, let's talk about this piece. You probably will need to clean up those edges of that dovetail to make it lock into whatever your mount is. This is the G24 mount on Amazon. It's like $80. Super good quality. I did a little review on it on TikTok talking about it. Everything is functional on it. It's solid. Tiniest amount of play right here, but you're not gonna notice that. Super solid. Would recommend. Alright. So you got, looks like a layer in here that didn't adhere fully, and it's just causing this issue, so we'll just cut that out. And you just line up them holes. We'll take our drill bit one, and we'll just bend it with the drill bit. If you don't have the holes right, it'll start pushing on this J-arm, and it'll probably snap your bridge. So just be cognizant of that. I don't think you can actually run a washer on this back side. I don't think there's enough thread for it to really grab. But let's see what we got. Ooh. Yeah, you can't really run a washer on that. Should be fine. It's not a super, it's not being stressed in that direction anyways. It's being stressed. Not really at all, honestly. Pretty low stress area. The bridge, you're gonna want to print your bridge vertically, so that way it, don't print your bridge like this. Don't print it flat like that. Print it vertically like this, so that way your layer lines loop around your bolt. Otherwise, when you turn this, if it's printed flat, when you turn this, it'll just snap your layer line. So just keep that in mind. Same with your J-arm. You print your J-arm, there's a flat side, then there's like a slightly angled side. Print it on the flat side. So that's that assembled right there. We'll talk about the helmet real quick. Let's see if I back the camera up a little bit. This is a bump helmet I got off of Amazon with a One Tigress helmet cover. I do not recommend these muffs. These are like air sew tack or whatever, something like that. They don't work as ear muffs. They have all these cords and wires and shit, so I thought they were electronic, but they don't have battery terminals. And I read the little paper it comes with, and it says battery no work model. So apparently this does not take batteries. I'm not going to return it because you can actually snap these head pieces off and you can put your own on there. And I have a decent set of muffs with mic and comm that I can hook up. As far as like the tension, they don't seem to tension to your head real well. I'm hoping that that fix that Grand Thumb did, where you go in there and you put a piece of paracord behind it, hoping that'll fix that tension issue. This is a Type 2 battery pouch. Type 2 is in a Navy working uniform Type 2. So it's just a basic battery pouch there. I probably will try and work on a hard battery pack at some point, but these soft battery pouches seem to work fine. As far as installing the battery, you open it up, there's some elastic strapping in there, and you can just take your battery, you can put it into the elastic, or you can just slide it in there and Velcro it, and you get your cord right here hanging out. This is that helmet cord I talked about. It's not actually a helmet cord, but it'll work for now. And so the only thing we got to figure out is how to connect these two together. And what I'm thinking is I'm just going to use two of these butt to butt, tip to butt, you know what they say, and call that good to go there. I'm going to run this cable real quick. I'll just run it on the outside of the helmet for ease. There are little threaded areas. This cable is plenty long. I want the 90-degree side to be on the helmet side, or on the goggle side, just to make life easier. We'll take our G24, make sure that that tab is on the inward direction, install it, lock it in, G24 is in. We'll take our dovetail, lock our dovetail there. I did something wrong here. Classic, wouldn't you know it. I actually installed this backwards. 1 second. Ooh. So this is what I meant when I said you gotta have those holes lined up or you'll crack this piece. This one was obviously printed not solid, because I didn't think it would really matter, but cracked it, clearly. But since it's literally a bolt going through it, holding the two pieces together, might as well just send it. Bolt through there, and because we broke it, we'll run a bolt through the other side as well. Where is that drill bit? Fuck, man. Whatever. Alright, so we're bolted together there. Even though that's cracked, it's probably fine for now. I'll print a new piece that's solid infill. Here we go. We have one monocle mounted and ready to go. You know, obviously swings to the right. Maybe you could run it with your left eye. I just keep it on your right eye. As for this power cable situation back here, I'll just real quickly fuck up my whole workshop area. This is where I think it could be beneficial to have a printed sack, we'll call it, in the back. And actually, you know what I was going to do? Instead of wasting two of these by connecting them both together, we'll do one. Because a lot of those batteries don't have connectors, 5.5. A lot of them have XT30 connectors. So we'll take this ye old XT30 connector. We will mate it before we solder so we don't ruin it. Sorry about the background noise. Probably hear a printer running. It's pretty quiet, but I mean, still a noticeable sound. It's printing another housing for me, which was supposed to be the second housing for this video. However, it's obviously not done, so. Alright, we're gonna I'm gonna solder up the, looks like this one wasn't fully cut. The only thing I don't like about these XT30s is I feel like it snaps off a lot at the end of them. I've had a lot of these snap off at the end, and it's not the solder joint, it's the wire being too thin, and it just wiggles back and forth a couple times and comes off. And that's really my only qualm with the XT30 connectors. I'm just heating up the solder on it. Pretty sure there's some wire chunk left in there. Chunks of wire. Get that out of there. And then pre-solder your wire a little bit. That was a hot spot for my finger to be. Pre-solder up your wire. This is a used XT30 connector, and that's why there's solder in it already. Actually, this is one that I took off of a harness that I previously had ready to go for my older design, where I used XT30 connectors in the design. It's this new one I wanted to be waterproof, and these are not waterproof connectors. So this is solder wick. Essentially it's just weaved together bits of copper wire, and you just press it on there and it sucks the solder out of your joint. So my camera died while I was recording, and I ended up finishing up the monocle. I realized that it had died, and I finished it up, attached it to the mount, created a small harness to connect the battery to the main wire. This design doesn't have a power switch yet. Probably will try and integrate one in the future. Might just leave that for the binocs. But since you missed all that footage, what you're going to get to see is this. It's a previous design iteration that I had that I printed. Works fine. I have a few updates to it. It's kind of ugly. It was printed in a draft mode. And you're going to get to see it take a little torture test. So this is for the people that think these plastic things are going to break from a drop. Not even denting it. The only place I think it would break is right here. But if you were to drop this thing, maybe the electronics would break, but the fucking housing is not. Oh, we do got a little crack there.
What?
There we go. Busted this one open. But as you can tell, obviously this one didn't print very solidly because there's a bunch of strands in there, not actual layers. As you can see, these things are pretty freaking strong. I designed them as strong as I could.